Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. We're going to talk about how to find the length of an arc, basically called the arc length, all right? Some textbook call it the length of an arc, some call it the arc length. You solve it the same way. All right, before I proceed, don't forget to like, share, and subscribe. Click the notification bell so that when I post new videos, you'll be the first person to know. All right, so before I proceed as well, please make sure you review previous videos so you understand some concept like what is an arc, what is a radius, what is the diameter. We've talked about that, what's the circumference. I talked about that in the previous video, so it's important that you do that as well. Now, so when we talk about an arc or we talk about an arc length, all right, the arc length is a portion of the circumference of the circle. So if we have a shape like this, so in the previous video, I told you that the circumference of a circle is the distance round it, right? The distance around the circle. So if, for instance, I decide to choose only a part of this circle here. So if I decide to choose only this part here, okay, of the circle, this is what we call an arc. Okay, so if I decide to choose just this part, I'm just only interested in this part of the circle, this is what we call an arc, all right? So this is what we call an arc, okay? So, and if you now want to extrapolate this a bit, we can now say that this can lead to, we can now break this down, that this can now lead to an angle as well, that you definitely have an angle for that arc length. So let's say in this case, we said we were interested in only this part, right? Okay, we said we're only interested in this part. We know as well that this is the center of the circle here. So if we now draw a radius to touch that part we're interested in, so it's from this part here all the way to this part here. Okay, so that means we have a radius here. Okay, we have the angle subtended by this arc. Let's call the angle here. And still, the distance here is called the arc length. Are you seeing it? So because I'm aware that some of you do take notes, I'm going to write this down. So basically, the arc length is a portion of the circumference of the circle. It's a portion, all right, of the circumference of the circle. Okay, so the arc length is a portion of the circumference of the circle. And now there are basically two types. There are two types of arc length. So we have what we call the major arc and we have what we call the minor arc. All right. So depending the question we have, some of the textbook we call a major arc, so we call a minor arc. So I'm going to quickly explain which of them. Let me first write what I just said. Okay, so there are two types. So there are types of arc length. Okay, so like I said, we have the first one, which is called the major arc. So while we'll be solving some questions, they could ask you the major arc, or they could ask you to look for the minor arc. All right. So how do you now differentiate both of them? So the major arc is basically greater than half of the circumference. So when the arc is greater than half of the circumference, it's called a major arc. And when the arc is less than half of the circumference, it's called a minor arc. So the major arc, so a major arc, all right, is greater than half the circumference. So when the arc length is greater than half the circumference, it's called the major arc. Then the reverse is for the minor arc. So a minor arc is less than half the circumference. Okay, so the major arc is greater than half the circumference, while the minor arc is less than half the circumference. So based on this now, I can easily then derive the formula now. So there's a way of deriving it, but I'm not going to go straight into it. So I'm going to just give you what the formula is, how to find the arc length. So the arc length is equal to, so the arc length. So remember here in the previous video, I told you that the arc length has an angle subtended by it, a theta, right? So if we now know that the arc length has a theta, then we can then easily find the arc length for this, all right? So for this now, we can now say that the arc length, we can now derive a formula using it. So we can now say the arc length, all right, will be equal to this angle we have here, theta, all right, divided by what? 360 degrees multiplied by pi times the diameter, all right? So we can now break this down further to be equal to theta over 360 times pi d. Okay, so theta over 360 times pi d. Now, but in some cases, like we saw in the previous video, you might be given the radius and you might not be given the diameter. And I told you in the previous video that the diameter is the same thing as 2 of the radius. So that means 2 radius or 2 radii makes 1 diameter, all right? So when you get a diameter, you divide it into 2, it will give you the radius, or 2 radii together, all right, will give you the diameter. So that means I can rewrite this again to be theta divided by 360 multiplied by pi multiplied by 2r, where r represents the radius, all right? So that means this is going to give us theta over 360 times 2 pi r. So you can use this formula or you can use the other what? Formula. So in this case now, we know where theta now theta represents the angle subtended by the arc length, okay? So the angle, or you can call it the sector. So the angle of the sector. So I'm introducing another terminology here, sector. So I'll talk about this more, or you can say the angle subtended by the arc length. Or you can say the angle subtended by the arc length, okay? So some textbook will say the length of the angle of the sector. Some will tell you the arc length, okay? The angle subtended by the arc length. So, but it depends. It depends which one you're talking about, all right? So, and also we know that the D is equal to the diameter. And R is equal to the what? The radius, okay? So the R is equal to the radius. So we've had that. So the arc length is equal to theta over 360 times pi d, or theta over 360 times 2 pi r, okay? Good. So, and also, I also made you to understand that they have two types. Okay, we have two types, and I told you that the first type we have the major and the minor arc. All right. So I explained that to you. We have the major arc and the minor arc. So the major arc is it's when the arc is greater than half the circumference, and the minor arc is when it's less than half the circumference. So the next step will be now, how do we now solve this? How do we solve this? We have 3 steps to do this. So you call it 3 steps, or you can call it 3 rules. It depends on how you want to go about it. So the first thing you have to do is that you have to identify the length of the radius or the diameter, all right? So the first thing you have to do is to identify the length of the radius or diameter. Okay, so then, and also it's also important as well to also identify the angle of the sector. So when you've identified the length of the radius or diameter and the angle of the sector, so that means you have to identify the theta. Then when you've done that, then you have to then substitute it into the appropriate formula. So the appropriate formula we talked about is when if it's theta over 360 times pi d, or theta over 360 times 2 pi r. So depending the variables or the information you were given in the question. So number 2, you then substitute into the appropriate formula. Okay, so you could use this formula, theta over 360, okay, times pi d. So in this case, is if you're given a diameter, or if you're given a radius, you can use theta over 360, all right, times 2 pi r, okay? We can use the small letter r for this, or 2 pi r. So when you're done with that, the next step is that you have to then what? Simplify. So number 3, you then what? Simplify. So the first thing you do, you identify the length of the radius or the diameter, as well as the angle of the sector. After that, you substitute it to the appropriate formula, either theta over 360 times pi d, or theta over 360 times 2 pi r. Then you then what? Simplify. Okay, so we're going to take some questions now. So let's take an example now, all right? So let's go to a new page. So let's take an example. All right, so let's pick an example. So I'll just pick maybe 2 or 3 examples in this case, or I might even throw in a 4th one, so that let's see and see how we can answer this kind of questions. All right, so number 1. So we have an example here where we're told to find the arc length of a sector of radius r is equal to 10 centimeter with angle 60 degrees. Okay, so we're told to find the arc length of a sector of radius r is equal to 10 centimeter with angle 60 degrees. So what do you do? So let's go back to the steps. So from the steps, I told you the first thing you have to do is that you have to identify the length of the radius or diameter and also the angle. So you have to ask yourself, you have to look at the question and ask yourself, Do I have the radius? Do I have theta? So let's go back here. So you can see step one. Okay, step one, we are given the R. So the R is equal to 10 centimeter. And we're given the theta, and the theta is equal to what? 60 degrees. Now let's go to step two. Step two now says we need to find the arc length by substituting into the appropriate formula. So that means we're given both R and theta. So we're going to use the second one here. So that means we're going to use the formula, step two. We're going to use theta divided by 360 multiplied by, we're going to use the one with radius. So that's going to be 2 pi r. Okay? So if we have that then, so we're going to have the theta will be equal to 60 divided by 360 multiplied by 2 times pi times, what is the r? The r we have is 10. And what does step three say? Step three says we have to then what? Simplify. So we go all the way to step three. Okay. Now you press this in your calculator. Just punch this in and it's going to give you 10 over 3 pi centimeter. Or you can also have it as 10.47 centimeter. Okay, so if you want to press this, you can just get that to your calculator and that will give you that. So let's pick another example. Let's take question 2 now. So I have an quick example here. So we said we're told to find the arc length of the sector below. Of the sector below. So we're given this sector and we're told to find the arc length. So how do you go about it? So we have, it looks like something like this. You have another straight line like this, and you had a curve all the way here. So we're looking for the length of the arc length, and we're told that this is 20 centimeter, and we have a sign here. Okay. So we have told that was 20, and we had the sign here. So let me write this centimeter better. Yep. So we had that now, and we're now told to solve this. How do you go about it? So step one, we need to identify the radius or the diameter. So the radius here clearly stated is 20 centimeter. All right. Now, what's the angle here? What will be the theta? The theta is going to be what? Because it's a right angle triangle sign. So that means this is a right angle sign. So a right angle means it's going to be what? 90 what? Degrees. Now, because that is 90 degrees, we can now go straight and substitute it in the formula. So step two, we know the arc length. Okay. The arc length is equal to theta divided by 360. Now, because we're given the radius, it's going to give us 2 pi r, all right? And that will give us theta here is going to be 90 divided by 360 multiplied by 2 times pi times what? 20. 2 times pi times 20. And step three, we have to what? Simplify. Step three, we have to simplify. And when you press this in your calculator, it's going to give us 10 pi centimeter or 31.42 centimeter. Okay. And that will be that for that. Okay. So basically, in this example, we identify the radius. We apply the formula of theta over 360 times 2 pi r. And we know that from this example that this is a right angle sign. So it means that this angle here is 90 what? Degrees. All right, so we'll go to the next example now. So the example I have here, number 3, okay, we're told to find the arc length of a semicircle. So find the arc length of the semicircle. Shown below, right? So we have this arc length here, and the shape we have is, because it's a semicircle, it means that it's half of a circle, okay? So it looks something like this, or this is not, let's use something else. This will not really represent what I'm looking for. All right, so that means I will just draw it with my hand then. All right, so what I'm trying to draw is something like this. So we have a straight line, okay? Then we have the arc length all the way to this point. So just like a smooth curve here. And we're told that this is 30 centimeter. And we're now told to find the arc length here. So let's go. So in this case here, the first thing you have to do, like we always say, you have to identify if there is a radius or a diameter. Now, if you look at this is basically the same thing as getting it from here. So what happens is, it's a complete circle, all right? And when we talk about a semicircle means a half of a circle, all right? So that means if you have a circle and you divide it into 2, so it's called a semicircle. So you're going to give it 2 semicircles. So basically what I'm saying is that just one of this, so that means you have one like this, and you're going to have another one like this. Are you getting it? So that means if it divides a circle into 2, that means the line segment here that divides it is called a diameter. Are you seeing it? So basically, it is a diameter that divides a circle into 2 equal parts. So that means the 30 centimeter here is a what? A diameter, and the diameter is 30, all right? Then, what do you think the angle is going to be? The angle on the straight line. The angle on the straight line is what? 180 degrees. So the theta here is going to become 180 what? Degrees. Now we've had that, we now go to step 2. All right, step 2. Now in step 2, now we can find the arc length. All right, we can find the arc length now. So now, but because we're given the diameter, we can use the formula theta over 360 times pi d. So because we have the diameter here, so that means this is going to give us equal to theta will be 180 divided by 360 times pi times the d is what? 30 centimeter. Okay? Then step 3, we simplify that. So basically what you do, you press this in your calculator to give you your answer. And when you press that, it will give you 15 pi cm, or in decimals, it's going to give us 47.12 cm. And that will be the answer for that. So in this concept, it's just trying to tell you that the diameter divides a circle into 2 equal parts. So if you have a circle and you have a diameter going through it to divide it, so the line that divides it here is called a what? A diameter. So this is just a concept. So this is what the question was just testing. We wanted to find out if you knew how to find the arc length of a semicircle, knowing that the arc length is usually going to go through the diameter, all right? So that means that you have to use the pi over 360 times pi d, all right? What I can do, I will just throw in the last question here, number 4. Just the last question for this video before I go to the next one on how to find the area of a sector. All right, so let's go. So we have find the arc length. Okay, of the semicircle. Or let's make it more interesting. So instead of me, let's go for another semicircle, which is similar to the last one. Should we try something that has a sector instead? Let's try a sector with a radius. And assuming they give you the arc length and they want you to find the angle or something. So let us try that instead, okay? Let's try something a little bit more interesting. So you can try these basic ones when you go to the textbook anytime. So let us assume we have that this a sector, all right? So let's assume that we're told that a sector, okay, has an arc length a sector has an arc length of 6 centimeter. So a sector has an arc length of 6 centimeter, and the radius. And the radius of, let's say, maybe 2 centimeter. All right. Now, let's say we are now to calculate the angle of the sector. So the angle of the sector. All right, so we have something like this. So usually what I always advise my students to do, I always advise that if possible, it's a very good practice to sketch. So if you can sketch it, so you can have a picture of what you're looking for. Is that okay? So let's have a look at this. All right, so we have, this is not going to be drawn to scale, definitely. So we have a sector. And we have it looking like this. Okay, so it could be a minor sector, a major sector. I'm going to talk about that in the next video, but I'm going to assume that this is a minor sector. But from the question, I can make an intelligent guess that's going to be a major sector. So that means technically it's going to should be looking like something like this. All right. But I don't want to confuse you. I don't want to go into that now. So I'm going to just assume that it's just a basic sector, but not drawn to scale. So let me just write it. So not drawn to scale. All right. So not drawn to scale. Okay. So the diagram we have here is not drawn to scale. So diagram, not drawn to scale. Okay, let's get that out. Because if I'm looking at this, I can assume it's going to be a major sector. Or I can assume that the theta is going to be about very close to 180 degrees because the arc length is almost 3 times the radius, okay? All right, but let's forget about that. Forget I said that. Let's just go straight to solve this. So based on this now, we have the radius is 2 centimeter, okay? And the arc length is 6. So they want you to find the angle here, theta. All right. So how do you find the angle here? All right, straight to the point. We know step 1, we're always told that we need to bring out the information we have. So we have the radius is equal to 2 centimeter. The theta this time we don't know. All right, we don't know what is that. But we also know that the arc length, we know the arc length is 6 centimeter. All right, we know the arc length is 6 centimeter. So when you know the arc length is 6 centimeter, we can then solve. Now from the formula, we know that the arc length is equal to theta over 360 times 2 pi r. So that means we know the arc length. We know 360, we know 2 pi r, but we are looking for theta. So what I always advise is that we can just make theta the subject of the formula. Okay, so let's make theta since we're looking for theta. So what I'm going to do, I'm going to multiply both sides by what? 360 degrees. So I'm going to multiply this by 360. I'm going to multiply this by 360. Or another way is, if you prefer, is that you can substitute it first and then you then make theta the subject. Or you make theta the subject, then you substitute. All right? So depending which one you want, all right, so we can just make theta the subject straight up. So this is gonna cancel this out. So we're gonna have 360 multiplied by the arc length is equal to theta times 2 pi r. Well, we're looking for theta here. So what do? So if you're looking for theta, you divide both sides by what? 2 pi r. So make theta the subject of the formula here. 2 pi r. So theta will be on its own now. So then we can now say that theta will be equal to 360 multiplied by the arc length, all right? Arc length divided by 2 pi r. So we can now substitute it. So we can now substitute that. So we're going to have 360 multiplied by what is the arc length? The arc length here is 6. We're told that it was 6. Divided by 2 times pi times what is the radius? We're told as well the radius was also 2. So when you press this in your calculator, theta will be 171.89 degrees. And that will be that for that. All right, so that means if for the sector here, the theta is 171.89 degrees. And that is that for that. So those are the examples we have here, and those are the examples we can play around with. Okay, that will bring me to the end for the examples on how to find the arc length. The next video I'm going to go straight into now will be how do we find the area of a sector. So it's very important that you subscribe and click the notification bell so that when I post the next video, you'll be the first person to know. All right. So I'll see you soon where we're going to talk about how to find the area of a sector. All right, see you soon.